In this video, we're going to go through our categorical data transformations for model preparation. Now, this is kind of a multi-step process, so we'll probably break it out into a couple different videos to make sure that we address each step appropriately. So we're going to add one more worksheet on after this quantitative transformation lab, and we're going to title it Categorical, or CAT even. Transform lab is fine. Okay, make sure you give it that lab suffix. Make sure when you do your homework using your homework subset that you give it that homework suffix. Okay, so the first thing that we're going to do is copy the variables that we need. We're just going to be focusing on the original variables that we were assigned. So we'll take house ID, burrow, overall quality, and sale price. Okay, and then we'll copy them into this new worksheet. Okay, now I want to go back and reference some of the previous analysis that we've done. Now, this isn't really a univariate reference. I should just call this a reference sheet. Just so we can look at the distributions as they originally were. Remember from that background lecture, we are focused on categories that are underrepresented. So we definitely need to take care of these poor and fair categories. They only have 1 and 15 observations in them each. Right here, just going to highlight them so that we know we have to address them. And remember, with the ordinal variable, we're going to combine these categories with the next category in the order. So we would combine very poor and fair with this below average category. Okay, now the other thing that we need to address here is this very excellent category. Okay, I'll try to shade this in a different color right here. This is also underrepresented. It has less than 30 observations. So we need to combine that with the next category in the order. We've confirmed that we see an increasing sale price as we move through these categories. We do note that we do have an increase in the variance as we move through these categories, but again, a lot of the reason for this is that the underlying distribution of that sale price variable is skewed. So when we transform that sale price variable, we'll take care of a lot of the differences in the variability among the categories. Okay. So when we look at the burrow variable, we have only one underrepresented category here. Okay, and here this is the Brookdale category. Okay, so now we have some decisions to make. So the least desirable option would be to remove all of those observations. We delete 21 observations. That's the kind of the path of least resistance. Or the path that we don't want to go down. Okay, we're going to choose that last. I guess most resistance. We're going to resist doing that unless it absolutely makes sense. And maybe we'll try it both ways. In this course, we're just going to go about it one way. In practice, maybe you would try combining it and see how it performed in the model, and then you would try removing it and see how the overall model performed either way. So the next thing that we need to do is decide which category we're going to combine it with. Well, for this, we can't really distinguish that these neighborhoods are same. Maybe Brookside is similar in name. However, that doesn't necessarily imply that these are in the exact same area or anything like that. So the method that we'd have to rely on is combining it with the category that was most similar in measures of center and spread. And if we look at that, that actually is the Brookside category. So we would combine Brookdale with Brookside, and it probably wouldn't change the overall statistics of Brookside that much. It might bring them down just a little bit, but overall it should stay about the same. The next thing that we might want to do is see if there's any other categories that we might want to combine. To me, I think with our relationship testing, we found that all of these categories were significantly different from each other. So there's no real justification for combining Crawford and Somerset, even though they appear to have, similar measures of center and spread. If you wanted to try it, that's totally fine. It's not a requirement. You can combine them, you can leave them separate. either or. That I think that's about the only one that I might consider combining if I were to do this. However, they appear to be different enough that I might leave them by themselves, and they're certainly well represented enough. Okay, so we're just going to combine Brookdale and Brookside. We're going to end up with 1, 2, 3, 4, 5 categories, and so we'll have 4 dummy coded variables to represent this. And then when we rank code this, we're going to end up with 1, 2, 3, 4, 5, 6 categories left. So then we'll rank code them 1 through 6. All right, so let's go ahead and set up our worksheet. We did that already. Now we know we're going to start with the first one in the worksheet, that's burrow, and we're just going to be combining Brookdale and Brookside. So we'll go to our categorical transformation. I'm going to add a new column of data right after burrow. Okay, and this is going to be burrow combined. Okay. And then we're also going to need, let's see, we're going to end up with 5 categories. So we're going to need 4 more columns for our dummy variables. Since we're going to end up with 5 categories after we combine them, then we're going to make sure that we have 4 dummy variables to represent those categories. All right, so for our burrow combined variable, let me put some filter buttons on this just in case I need them. Okay, we see the 4 categories. I want to make sure that I have their spelling correct. BR Dale is for Brookdale and Brookside. So we'll just, when we combine them, we'll call them Brook, since that's the first name of both of these groups. Okay, or we can combine Brookdale with Brookside, either or. And we're going to do this with an if statement. Okay, so let's think logically through this. Okay, if this equals BR Dale, that's how it was represented in the underlying data, then let's just combine it with Brookside to keep it simple. BRKSDE, I believe is how Brookside was represented. We can go back and double check that. Now, we're not combining any categories. So if it is Crawford, if it's North Ames, if it's Somerset, if it's any of those other neighborhoods, we just want it to return itself. So we actually only need one if statement here. And so if it doesn't meet the criteria of being in Brookdale, then hence be combined into Brookside, then we just want it to return itself. Okay, so that's exactly what happened here. I just want to go verify. Oh, that Brookside has an I in it, so I need to make sure that I do add that I there. Okay, then after we've created that variable, we'll fill that down to the bottom. And if we look at those combined categories, now we only have one Brookside category because all the Brookdale observations are now in that Brookside category. We have Crawford, North Ames, Northridge, and Somerset. Okay, so we have 5 categories left, and we're going to need 4 variables or dummy variables to represent that. So I'm going to create a dummy variable for Crawford, for North Ames, for Northridge, and Somerset. And my Brookside category is going to be what's called the reference category. So when I get a 0 for this dummy variable and a 0 for this dummy variable and a 0 for this dummy variable and a 0 for this dummy variable, then that means it has to fall into this, this reference category, Brookside. Okay, so we're going to do Crawford dummy. We're going to do North Ames dummy. We're going to do Northridge dummy. And we're going to do Somerset dummy. Okay, now basically this is just an on and off switch. If I see a Crawford neighborhood, I'm going to give it a value of 1. If I see anything else, I'm going to give it a value of 0. So these are just simple if statements. So if this combined variable now equals, in parentheses, all um, lettered variables have to be in parentheses or lettered categories. Then we're going to give it a value of 1. The 1 is not in, not parentheses, quotations. The 1 is not in quotations. So if it is a categorical label, it has to be in quotations. If it's a numerical value, it does not need to be in quotations. It shouldn't be. So what this is saying is if the burrow combine equals Crawford, give it a value of 1, indicating that that's the Crawford neighborhood. If not, give it a value of 0, indicating that it's one of the other neighborhoods. Okay, so we're just going to end up with a column of 0s and 1s. Okay, anytime it sees a Crawford neighborhood, it gets a value of 1. Anytime it sees anything else, it gets the value of 0. We'll do that same, apply that same logic here. So equals if, open parentheses, this burrow combined equals, open quotation, NAMES, close quotation. So that's our logical statement. If it equals North Ames, turn that switch on, give it a value of 1. If not, if it's in any of the other neighborhoods or boroughs, give it a value of 0. Okay, so it got a 0 because this first one's Crawford. When I fill this formula, when it hits a North Ames neighborhood, it's going to get a value of 1. Okay, and any of the other neighborhoods will be 0. Applying that same logic, equals if, open parentheses, this burrow combined variable equals North Ridge, that's NORIDGE, as it appears in the raw data. Okay, give it a value of 1, otherwise give it a value of 0. So just turning that switch on if it's in the North Ridge neighborhood or borough, and off if it's in any of the other boroughs. So it got to 0 because this is Crawford. We'll fill that formula, and we'll see that only when it encounters a North Ridge neighborhood does it turn that switch on. And then lastly, if this equals Somerset, give it a value of 1, otherwise give it a 0. Okay, we'll go to the bottom right corner, double click to fill that formula down. Okay, I must have typed it wrong. Yep, I need to be, because I see that Somerset here is not getting a value of 1. So you do need to go and double check to make sure that it's categorizing everything. I also see it's just a list of 0 values, and I know I have neighborhoods and or observations in the Somerset borough. So double click this, just remove this E to make sure that it's consistent with the spelling in the underlying data. And then refill that formula, and now I can see when it does encounter a Somerset observation, it does turn that switch on right here, right here. And then for all of the other neighborhoods, North Ames through Brookside, through Northridge, all of these other ones, it's going to give it a value of 0. So, and then again, I don't need to have a dummy code variable for that Brookside variable. If we look at this right here, when it has a Brookside label, it just gets 0s across the board. For Crawford, it gets 1 and 3 zeros. For North Ames, it gets 0, 1, and then 2 zeros. For Somerset, it gets 3 zeros and then a 1. So we're just kind of creating a series of on and off switches that lets the model know this is in this neighborhood, this is not in this neighborhood, this is in this neighborhood, this is not in this neighborhood, so on and so forth. So when we build our data set for our final model, these are the columns of data that you take into that final model worksheet. Remember, all of these variables have to be in numerical format in order to be used in that final regression model.